Good morning, dear students. Welcome back again with a new session of Standard 10, lesson number 7, lens. Subtopics of these lessons are already we have done it. Now we are going to start with the topic of sign convention of the lens. In order to understand the sign convention of the lens, we have to understand how the graph is being plotted. If you understand the concept of plotting of the graph, we can easily understand the concept of the sign convention of the lens in convex lens as well as in concave lens. Now, as the terms were used for the mirror, same terms are used for the lens, like U, V, H1 and H2. U implies object distance, V implies image distance, H1 implies height of the object, H2 implies height of the image. Now, in order to explain the sign convention properly, one paragraph is being mentioned here in green color. According to a Cartesian sign convention, the optical lens O is taken to be the origin. The principal axis is the x-axis and the frame of reference as the frame of the reference. The sign convention is as follows. The object is always placed on the left of the lens, so all distance parallel to the principal axis are measured from the optical center O. The distance measured to the right of the O is taken to be positive and to the left of the O is taken to be negative. Similarly, a perpendicular distance above the principal axis is taken to be positive and a perpendicular distance below the principal axis is taken to be negative. The focal length of the convex lens is always taken as positive while that of concave lens is taken as negative. That will depend upon the object and the image distance. Now, in case of concave lens, image is always forming on the image is forming on the sorry object is on the left hand side and image on the right hand side. On the left hand side, both are negative, so negative term gets cancelled, and therefore for concave mirror, sorry, I'm very sorry. Here, in case of concave lens, you can see here the diagram of the concave lens. Object distance and image distance both are taken to be negative. Okay, so here focal length is nothing but distance from the optical center to the position of the image, which is always on the left hand side, and therefore focal length of concave lens is always negative, whereas in case of convex lens it is positive. Now, similarly, as it was in concave and convex mirror, same terms are used in lens also for magnification. The magnification due to the lens is the ratio of the height of the image h2 to the height of the object h1. Magnification equals to height of the image upon height of the object, that is m equals to h2 upon h1. Equation 1. Now this is with respect to the height. Magnification can also be found out with respect to the object and the image distance. So here the magnification of the formula also can be written as distance of the image upon distance of the object, that is m equals to v upon u. Now, what will happen in case if two lenses are being used together? So that is a combination of lens. For that, the formula is there, that is 1 upon f equals to 1 upon f1 plus 1 upon f2. Now, power of the lens. The capacity of a lens in to converge or to diverge the incident ray is called as power. The power of the focal length depends upon the degree of convergence and divergence. Also depends upon the focal length. Now, power is the inverse of the focal length. That is, F is expressed in meters, whereas power is expressed in diopters. Here the formula is P equals to 1 upon F in meter. In case of unit, it is written as 1 diopter equals to 1 upon 1 meter. Now, based on this formula, sums are being there, which is given in the short example. Now, we'll move ahead with the other subtopic of this lesson, that is human eye and the working of the lens. That we'll discuss in short. There is a very thin transparent cover membrane on the human eye. This is called as a cornea. You can refer to figure 7.11. The thin layer out the surface of the eye, which is called as cornea. The light enters to the eye through it. Maximum amount of refraction takes place through the cornea. Then below the cornea there is a dark fleshy screen behind the cornea. This is called as iris. The color of iris is different for the different person. That is depending upon the eyes. That depends upon the person to person. It may vary the color of it. Now sometimes it is very dark. In some cases it is gray color. Some cases brown color is also there. So that will vary from person to person. There is a small hole of there is a small hole of changing the diameter of the center of the iris, which is called as pupil. The pupil controls the amount of light entering the eye. If the light falling on the eye is too bright, then the pupil contracts. Whereas in case the light is dim, the pupil expands, or you can say it relaxes, so that maximum amount of light can pass through it and we can perceive the images very much clearly. Now the nature of the image. Inside the lens or inside the eye, the lens which is used is nothing but convex lens, and therefore the image formed is uh, real and inverted. The screen is made up of light sensitive cells and is called as retina. These cells gets excited when the light falls on them and generate electrical signals. These signals are conveyed to the brain through the optic nerve. Later, the brain analyzes these signals and converts them into such a way that we perceive the objects as they actually are. So it is a process where light rays falls on the retina connected to optic nerve to the brain, and then brain adjusts it and observe the object as it is. While seeing the objects at large infinite distances, the lens of the eye becomes flat and the focal length increases as shown as a part of the figure 7.12. You can see here 7.12. When the object is at very far away, what is happening? While seeing the objects nearby, the lens becomes more rounded and the focal length decreases as shown in figure part B. You can see when the object is very far away, lens is enlarged. When the object is nearby, the lens becomes rounded, or you can say the focal length of the lens becomes very small. This way we can see the objects clearly irrespective of the distance. The capacity of the lens to change its focal length as per the need is called as power of the accommodation. Although the elastic lens can change its focal length to increase or decrease, it cannot do so beyond certain limit. So it has certain capacity to increase or decrease the focal length of the lens. Beyond that, the lens does not lens may not work it out. We may not be able to perceive the object. Now, after this, certain topics are there which we'll discuss it in the next video. Till then, have a great day.